These examples go with lesson 8.3, hypothesis tests for a population mean, standard deviation unknown. Example 1. Find the p-value for the following values of the test statistic t, sample size n, and alternate hypothesis h1. Okay, part A, the test statistic is 2.584, n is equal to 12, and the alternate hypothesis mu is greater than mu 0.0. This is going to be a right-tailed test, which we know because of the greater than sign here. The degrees of freedom will be 12 minus 1, or 11. And when we go to find our p-value, we are going to be looking on line 11 of table A3, and we are going to try and find 2.584 inside the body of table A3. So let's go to table A3. Right here is line 11. Remember, we're looking for 2.584. This is 0.2, 0.6, 1.3, 1.7, 2.2, 2.7. So I've gone too far here. 2.7 is more than that. 2.2 is less than that. So what I know is that my test statistic falls in between these two values that are in my table. And if I read up the column, the p-value for the 2.201 is 0.025, and the p-value for 2.718 is 0.01. Okay, so here's what we can say. We know that 2.201 is less than our test statistic, 2.584, and that is going to be less than 2.718. That means the p-value that goes with 2.584 should be in between the two p-values for these numbers. Now, the p-value for 2.718 was 0.01, and the p-value for the 2.201 was 0.025, and I'm not going to leave it like this because 0.02, which does go with this number right here, is not less than 0.01, which 0.01 goes with this right here. So I'm actually going to switch these two around to make my inequality be a true statement, and then I'll have my interval for the p-value. So let's take those away. And we'll put our 0.01 on this side and our 0.025 on this side. All right, and there's our answer for A. We can't get a specific p-value with table A3. We can only get an interval for table A3. But if you want, you can use the ALEKS calculator and you can get the exact value for the p-value if you want to. So let's look at that. We'll pull up the ALEKS calculator. And the key you're looking for is right down here on the 5th row. It's this one. The PT is greater than. The first box, you're supposed to put your test statistic in. That was 2.584. Not taking, hang on. And then the second box, you're supposed to put in your degrees of freedom, which we said was going to be 11. And then push enter, and it gives us our p-value there of 0.0127. This we got for the ALEKS calculator. And this number, as you can see, does fall in between 0.01 and 0.025. Okay, so if your test statistic does not appear in table A3 and you're going to use table A3, you're going to have to do it with an interval. Or if your test statistic is not in table A3, then you can use the ALEKS calculator. Either one of those is going to work. All right, let's look at B. The test statistic negative 1.741. We're doing a left-tailed test this time because of the less than. And our degrees of freedom are going to be 20. So we're going to be looking on line 20 to see if we can find 1.741. Now remember, we're going to look for the absolute value of this, or the positive, because remember the miracle of symmetry there. Okay, so 1.741, line 20, 1.725, 2.086, we know that our value falls in between 1.725 and 2.086, which means our p-value will fall between, let's see, 1.725, that's going to bring us up here to 0.05, and 2.086, that's going to bring us up here to 0.025. Therefore, the interval that contains negative 1.741 is going to be between 0.025 and 0.05. Now, if we want to get the exact one, we can use the ALEKS calculator. All right, so we brought up the ALEKS calculator here. We're down here on line 5. We want the PT is greater than. And our test statistic was 1.741. And the degrees of freedom, we said, was going to be 20. And that gives us 0.0485. So our p-value here .0485, and that does fall clearly within our parameters for the p-value. All right, part C. T is equal to 3.031, n is equal to 14. We are doing a two-tailed test, and we know this because of the not equals. And that means that once we have our p-values, we are actually going to have to double them, but we'll have to figure out what the p-values are first by using table A3. Okay, our degrees of freedom are going to be 14 minus 1, so that's going to give us 13 degrees of freedom. We're going to look on table A3, line 13, we're looking for 3.031. Here's line 13. 3.012, 3.372. So 3.031 is going to be in between these. Okay, so 3.012 is less than 3.031, and that is less than 3.372. All right, let's see what this is going to do to my p-value. 3.012, the p-value that goes with that is going to be right here, 0.005. And then 3.372, also on line 13, 0.0025. Now let's go to the ALEKS calculator and let's get our exact p-value. We're looking, oh wait a minute, we have to double those, don't we? That's right, because this is a two-tailed test. So let's take that part off. There we go. All right. We're supposed to double everything because it was a two-tailed test. So let's see, 0.0025. If we put that in the calculator, that's going to give us 0.005. And then when we double 0.005, that's going to give us 0.010. There we go. So the p-value for this particular test should fall between 0.005 and 0.010. All right, now let's pull up the ALEKS calculator and let's get the exact p-value for this. We got 3.031. Clear this one out. 3. And we said there were 13 degrees of freedom. And that gives us 0.0048. And I realized that our p-value here, 0.0048, actually does not fall inside this p-value interval right here. And that could be due to some rounding that happened back in here or over in here to get to this particular situation. So we do know that this p-value will round up to 0.005. All right, let's look at part D. The test statistic negative 2.584. N is equal to 31. Once again, we're doing a two-tailed test, so we have to remember to double those p-values. The degrees of freedom for this problem will be 31 minus 1, or 30. And we will be looking on line 30 for 2.584. Line 30. 2.4, 2.45, 2.7. So it's going to be between 2.457 and 2.750. That means that the p-value is going to fall in between what two values? 2.457 has an alpha value of 0.01, and 2.750 has an alpha value of 0.005. And then because of the two-tailed test, we're going to have to multiply this by 2. That means our p-value should fall between 0.010 and 0.02. And we can pull up the ALEKS calculator and get our exact value for this. with 30 degrees of freedom. 0.0074. And again, our p-value does not fall within our range here, but again, I am attributing that to a rounding error somewhere earlier on in the problem before we actually got to these numbers to try and test them. Example 2. The sample size is n is equal to 41. We observed a sample mean x bar is equal to 2.2 and a sample standard deviation s is equal to 6.1. The test is the null hypothesis mu is equal to 0 versus the alternate hypothesis mu is greater than 0. First thing we're going to do in part A is we're going to find the value of the test statistic. The formula for the test statistic is the sample mean minus mu 0 divided by the sample standard deviation divided by the square root of n. So in our case, we're looking at 2.2 minus, now remember mu 0, we can find that over here in the alternate, in the hypothesis, in the null hypothesis. In this case, it's going to be 0. We are dividing by the sample standard deviation divided by the square root of n. All right, and let's put that in the calculator and see what we get. And this is giving me 2.3093, which will be our test statistic, 2.3093. Okay, part B. How many degrees of freedom are there? Well, the degrees of freedom, remember, are just one less than our sample size. So in this case, our degrees of freedom will be 40. Part C, find the p-value. Okay, if we use table A3, then we're going to go to line 40, and we're going to try and find 2.3093. Line 40, right here, 2.3, all right, there's 2.4, there's 2.021. 2.021 is less than our test statistic, 2.3093, and this is less than 2.423. We are doing a right-tailed test here, and our p-value is going to fall in between, let's see, 2.021, this is 1, 2, 3, 4, 5, okay, 1, 2, 3, 4, 5, so this is 0.025, and then the 2.423 at the 0.01. The actual p-value from the ALEKS calculator with 40 degrees of freedom, 0.0131. Now, please understand, you don't have to find both an interval and the actual p-value. I'm just giving you two options here, and I think you might be better off using the ALEKS calculator and getting the actual p-value for it, because I don't remember if ALEKS allows you to put the interval in or not. All right, part D, is the evidence against the null hypothesis stronger or weaker than the evidence from the sample mean when n is equal to 76 and p is equal to 0.0012. And then we're going to explain our answers here. We are comparing the p-value that we found here against the p-value that was found in another experiment. And remember, we said the smaller the p-value is, the stronger the evidence is against the null hypothesis. So our p-value is actually weaker evidence because our p-value that we found is more than the previous p-value. All right, and here's our explanation. It is weaker because the p-value 0.0131 is greater than 0.0012. Example 3. In a test, the alternate hypothesis was mu is not equal to 3.5, and the p-value for the two-tailed test was p is equal to 0.0256. What would the p-value be for the alternate hypothesis mu is less than 3.5? So what they're asking is, how is this p-value right here going to change if I go from a two-tailed test down to a left-tailed test? Well, remember, when I'm doing a two-tailed test, I had to double my p-value. And that means that if I'm going to back down to a one-tailed test, in this case a left-tailed test, then I have to undouble that. In other words, the p-value for this test right here, mu is less than 3.5, is simply going to be the p-value I got from the two-tailed test divided by 2. And that's going to give me 0.0128. Example 4 is just practice in reading the screen from a p-value test that was done on a TI-84. So the following screen is from a TI-84 Plus display, presents the results of a t-test. Part A, what are the null and alternate hypotheses? Well, our TI-84 only gives us the alternate hypothesis right here, that mu is less than 7, and that means that we're doing a left-tailed test. The alternate hypothesis we can deduce based on what the alternate hypothesis is. So the null hypothesis we can deduce based on what the alternate hypothesis is. And that's going to be that mu is actually equal to 7. And then the alternate one they gave to us, mu is less than 7. All right, B, what is the sample size? That's given to us right here. It's 6. How many degrees of freedom are there? Now this is not on the screen, but we can get it pretty quickly because we know the degrees of freedom is just one less than our sample size. In this case, that'll be 5. What is the value of the sample mean? That's given to us right here, 6.68. What is the value of the sample standard deviation? That is given to us right here. That is our SX, and that is going to be 0.205. What is the value of the test statistic? That is given to us right here. This is our t-value, and we can just round it to 3 or 4 decimal places. So negative 3.8236. And then part G, what is the p-value? Well, that's given to us to be right here. That's 0.0062. And then part H down here, are we going to reject the null hypothesis at the 0.01 level? Well, our test was going to be, is our p-value less than or equal to the alpha value? Because if it is, that's when we want to reject our null hypothesis. And our p-value, 0.0062, we're trying to figure out if that's less than or equal to 0.01. Yes, it is. So we are going to reject our null hypothesis. Example 5. From example 4, if the sample mean were 6.8, what would the p-value be? And here is a reminder of the information we had from example 4. The mu 0 was 7, the standard deviation for the sample was 0.205, and the sample size was 6. And here is our new mean. So if we're going to find the p-value, we need to find a new test statistic. And the formula is, we want to take our mean and subtract the mu 0 and divide that by the sample standard deviation, which should be divided by the square root of n. All right, so let's put that in the calculator and see what we get. And this is giving me negative 2.3897. All right, let's pull up the ALEKS calculator and get that new p-value. All right, we're down here on line 5, 2.3897 with 5 degrees of freedom gives me a p-value of 0.0312. So this would be the p-value if the sample mean changed to 6.80. Example 6. Find the critical value or values for the following values of the significance level alpha, sample size n, and alternate hypothesis h1. In part A, the alpha value is 0.05, n is equal to 3, and the alternate hypothesis mu is greater than mu 0. This is a right-tailed test. The degrees of freedom will be 2. And so we're going to pull up table A3, and we're going to find our critical value by looking on line 2 and the column 0.05. Line 2, column 0.05, right here, 2.920. Part B, alpha is equal to 0.01, n is equal to 26, and the alternate hypothesis mu is not equal to mu 0. That makes this a two-tailed test. The degrees of freedom will be 25, and our critical value we can find on table A3. We're going to go to line 25 under column 0.01. Column 0.01, line 25, this is 2.485. And we have done something wrong here because this was a two-tailed test. Keep in mind, when we have a two-tailed test, we're looking for this value here and this value right here. And the p-value, remember, were these two sides added together. So I wanted my whole shaded parts here to add up to 0.01. That means that half of it is going to go on this side, and the other half of it is going to be going over here on this side. And so I just looked up the wrong, under the wrong column. I shouldn't be looking under 0.01. I should be looking under half of 0.01 or 0.005. So let's try that again. Line 25 under 0.005, our critical value. 0.005, line 25, here it is, 2.787. That's this one right here. The other one's going to be negative 2.787, right, through the miracle of symmetry. That'll be this one right here. So this one actually had two critical values. We had a positive and a negative critical value. And that was all because of the two-tailed test. Part C, alpha is equal to 0.1, n is equal to 81, and the null hypothesis, the alternate hypothesis is that mu is less than mu0. This is a left-tailed test. The degrees of freedom will be 80. And the critical value will come off of table A3. We're going to be on line 80. And point 1, the column point 1. So line 80, column point 1. Let's see, column point 1 is right here. So this is 1, 2. This is the third one over. Line 80, 1, 2, 3. There it is, 1.292. And in our last one, part D, alpha is equal to 0.05, n is equal to 14. Once again, y'all, we're doing a two-tailed test. Our degrees of freedom are going to be 13. And we will find the critical value, but remember, we're going to have to divide the alpha value by 2, because when we do a two-tailed test, we want to find both the shaded areas, the one on the right and the one on the left. And so this tells me I'm actually looking for 0.025. All right, so I'm going to pull up table A3, line 13, column 0.025. Line 13, column 0.025. Here it is, 2.160. And let's not forget the negative 2.160, because we are actually finding a right term and the left term over here.